So one question from a survey was, how many credit cards do you currently have? The results of the survey were provided. Complete parts A through G. So let's look at our data here. I'm definitely going to want to use StatCrunch for that. So I'm going to go ahead and click, because it's going to, the first question is find the mean. I'm guessing the second one's going to be standard deviation. So let's open in StatCrunch. Okay. I'm just going to go ahead and relabel this number of cards. Don't have to do that, but I like doing that. And let's find the mean. So just go to Stat, Summary Stats, Columns, and number of cards, and press Compute. So there's our mean, 3.11. And it says do not round, so hopefully that'll work. Good. Standard deviation, let's go back to that summary stats. And our standard deviation is, it says 3 decimal places, so 1.890. Now it wants us to find a probability distribution for the random variable x. So let's go back to StatCrunch. And I can go to Stat, Tables, and just create a frequency table. Number of cards, and just make sure that relative frequency, which really is the probability here, and then press Compute. And there we go. So one card happened 13 times, which we don't need. We really don't need this number here. It's the 0.13 that we need. And do the same for the rest of the values. Okay, as you see, I went ahead and filled the rest of those out based on the relative frequencies. Go and remove our table there. Now we're going to draw a discrete distribution of the random variable x. And again, we can kind of see what's going on here. We start off at 0.13, we shoot up, so 2 and 3 are about the same, and then it comes back down. So my eyes are going over here to D, and I can blow that up a little bit. Yes, that's it, right? Or, as I've shown you before on other ones, we can use StatCrunch to create this plot. Let me go ahead and do that. So let me go back here to the frequency table that I just created, and I can put store in data table. All right, so here they are right here. And I can actually remove the frequency count. Don't need that for this particular one. And I'm going to go to Stat, Calculator, and Normal. Sorry, Custom. So X is the second number of cards, and then weights are in relative frequency. And there we go. And that looks just like D. So describe the shape of the distribution. This distribution is, we got one mode. Could be made a case that you have two modes because you have two peaks there. Many would consider that one spike right there. And skew to the right for sure. I mean, if you said bimodal there, I'd definitely give you credit because there are two values, 2 and 3, that basically have the same, near the same probability, near the same count. Determine the mean and standard deviation number of cards in the probability distribution found in part C. So our mean here at 3.11 should look familiar. Standard deviation, if I come back over here, I've got 1.88, 1.881, I guess, if I round that 9 to the 0. Determine the probability of randomly selecting an individual whose number of credit cards is more than 2 standard deviations from the mean. Is this result unusual? Okay, so we can see here we have the mean of 3.11, standard deviation of 1.881. So 2 standard deviations above the mean is this 3.11 plus 2 times 1.881, which is 6.872. And then 2 standard deviations below the mean is 3.11 minus 2 times 1.881 is negative 0.652. So we want to know there's more than 2 standard deviations from the mean. So that means above and below, but we can't be so our cut score was a negative on this one. So really all we care about is more than 6.872, which is really, with a discrete distribution, just 7 or more in this case, right? So we can come over to we can either take these and add these values here. So 2, 4, 5, 6, 7, so 0.07, or I can use my little calculator here, put in greater than 7, and I get 0.07. Either way is fine. The result, so is the result unusual or not? So remember, our general cut score at this point is 0.05. If it's less than 0.05, we say that's unusual. We had to come up with some number, and for now, that's what we're calling our threshold at 0.05. So it's not unusual because the probability is actually greater than 0.05. Part G, determine the probability of randomly selecting 2 individuals who are listed exactly, who are issued exactly 2 credit cards. Hint, are the events independent? Interpret the results. So, a couple ways to do this. If we look over here, so exactly 2 cards, so 2 people. So the first one is, they're 31 out of 100, right? So 31 out of 100, or 0.31, times, now we have to, we're selecting without replacement. So technically we would need to do 31 over 100 times, now how many people are left in the pool that have 2 credit cards? Right, 30. And how many people total are there? Good, 99. So we multiply those together. And that's going to give us 0.094. Now I'll be honest, when I first did this one, the numbers were big enough that I just assumed independence. So I just did 0.31 squared. So 0.31 times 0.31, and it's pretty close, 0.096 and 0.094. So if this were not a MyStatLab question, I would give you perfect credit for this. If the numbers are really small, like if we only had 20 people and we're not doing replacement, then you would probably need to back these out. But with this number, it seems close enough to me. But we're off by 2 1,000ths of a probability point. So, but 0.094, I believe, is what they're looking for. We'll find out. Good. Okay, interpret this result. Select the correct choice below and fill in the answer box with your choice. So again, think about what probability means. So if 2 people were randomly selected and surveyed 100 different times, the surveyors would expect about, and I guess we're going to round here, round to the nearest whole number is needed, right? About 9 of the surveys, 9.4% of 100, right? To result in 2 people with 2 credit cards. Okay, so I hope that helps.